Hello, today we are going to look at GCE 2023 Advanced Level Pure Mathematics with Mechanics Paper 1. We will be focusing this time on the section B, which involves mechanics. Okay, we start straight away with the first question in that section. The question is from linear kinematics. It says the position vector of a particle is r equals t cubed plus 2t squared plus 2 bracket I plus t squared minus 1 bracket j, all that given in meters at time t seconds. The acceleration of the particle when t equals 1 is, and you have 4 options to choose from. So the first thing we have to note is that to have the acceleration when position vector is given, you have to differentiate that position vector twice. That means getting the second derivative of the position vector with respect to t. Now, when you differentiate the position vector with respect to t, you will get the velocity vector. So we start by getting the velocity vector, which is the derivative of the position vector with respect to t. If I write my result in column form, the component of I in the velocity vector should be the derivative of the I component with respect to t, which would give 3t squared plus 4t plus 0, since the derivative of 2 with respect to t is 0. And for the derivative of the j component with respect to t, we have 2t, because the derivative of t squared is 2t, and the derivative of negative 1 with respect to t is 0. So the acceleration vector then should be r dot dot, which means the derivative of the velocity vector with respect to t. And in column form again, I will get 6t plus 4, while the j component will just be 2. Now, when t equals 1, I will get the acceleration vector as 10, 2. That means the I component of the acceleration vector will be 10, while the j component will be 2, and that corresponds to option D. In the second question, we have that a particle is projected from a point on a horizontal plane with speed 10 meters per second at angle 30 degrees to the plane. Taking g as 10 meters per second squared, the greatest height attained by the particle is, and we have these options. Remember, the maximum height attained by a projectile is given by u squared sine squared theta all over 2g. So directly we have all the information. So the speed u is 10, so 10 squared, and we have sine theta, where theta is 30 degrees, sine theta is half, and so sine squared theta should be half squared, which is 1 over 4 divided by 2 into g being 10. So we have 10 squared 100 divided by 4, which is 25, divided by 20. 25 divided by 20 should be 5 over 4, which corresponds to 1.25. So the maximum height is 1.25 meters, which corresponds to option B. The next question says the work that must be done to compress a spring of modulus 500 newtons from its natural length of 0.1 meters to a shortened length of 0.01 meter. So the first thing we have to do is to get the compression, which is normally the initial length minus the final length. So the compression E should be 0.1 minus 0.08, which gives 0.02. The work done in compressing the spring is equal to the elastic potential energy, which corresponds to the modulus of elasticity times the square of the compression divided by twice the natural length. That gives 500 into 0.02 squared all over 2 into 0.1, and when you simplify that, it gives you 1 joule, which corresponds to option A. In the next question, we have that a particle of mass 4 kg is moving in a horizontal circle of radius 2 meters with angular speed of 3 rads per second. The centripetal force acting on the particle is, and we have these options. Remember, centripetal force, the force that causes an acceleration towards the center of circular motion, is given by mv squared over r, where v is the linear speed, or we can also have the alternative version of it, which is mr omega squared, when you replace v by r omega. And here we have the mass as 4, radius as 2, and the angular speed as 3, all that squared, so it gives 8 times 9, which is 72 newtons. So the answer is option B. In the next question, we have that 3 particles of weight 7 newtons, 9 newtons, and 4 newtons have position vectors 4i plus j, 3j, and 3i plus 4j, all in meters respectively. The position vector of their center of mass is, normally to have the I component of the position vector of the center of mass, I would use the formula x bar equals summation from I equals 1 to 3 of the weight times the I component of the position vector of the individual weight over the sum of the individual weights. To do this, we simply multiply 7 by the I component, 9 by the I component, and 4 by the I component. So from here, we have that 7 multiplies the I component of its position vector, 9 multiplies the I component there, which is 0, while 4 multiplies so I have 7 into 4 plus 9 into 0 plus 4 into 3 all over the sum of the weights, which is 7 plus 9 plus 4. That gives 28 plus 0 plus 12 all over 7 plus 9 plus 4, which corresponds to 20. 28 plus 12 is 40, and 40 divided by 20 is 2. In questions where you have to do 2 calculations, always be strategic. If we observe carefully, we see that x bar already can give us the option we need, because in all the options, it's only in option B where the I component of the center of mass is 2, and so our correct option is B. You can verify that y bar will give you 5 over 2 by doing the calculation. In the next question, we have that figure 1 shows a uniform sheet of metal in the form of the letter T with dimensions in meters. So we have this shape. The distance of the center of mass of the sheet from the edge AB is, and we have the options given. So in order to solve this question, we need to strategize by dividing the metal sheet into 2 rectangles. There is rectangle, the first rectangle, whose area we're going to denote as A1, and the area will be length times width, which is 4 times 2. It gives 8 meters squared, while the second area would be A2, and the area corresponds to the length, which is 6 times the width, which is 2. So 6 times 2, which gives you 12 meters squared. We're going to use area in the calculation of the distance required, because for a uniform lamina, area is directly proportional to mass, which in turn is directly proportional to the width. We need to find the distance of the center of each of the components there from the HAB. So we have from the center to the HAB that distance, which corresponds to y1, and that distance is 2 units plus 2 units, it makes 4 meters, while the distance of the center of the second rectangle, y2, corresponds to 1 meter. Y2 corresponds to 1 meter. And then we will calculate that distance as y bar, corresponding to a1 y1 plus a2 y2 all over the sum of the areas a1 plus a2. And that gives us a1, which is 8, into y1, which is 4, plus a2, which is 12, into y2, which is 1, all over the sum of the areas, which is 8 plus 12. Now 8 times 4 is 32, so 32 plus 12 times 1, which is 12, all over 20. That gives 44 over 20, which is 2.2. That gives option C as the answer. In the next question, we have a uniform ladder AB of length 2A rests with its upper end B against a rough vertical wall and the lower end A against a rough horizontal floor. The forces acting on the ladder AB are shown in figure 2. So this is figure 2 shown with the forces on it. Given that AB is in limiting equilibrium, the angle theta which AB makes with the wall is, and you have the options of the angle given there. In order to avoid finding the friction of the wall, which has not been included, we'll take moments about the top of the ladder. When you take moments about the top of the ladder, the lines of action of the 10 Newton normal reaction of the wall and the friction of the wall, since they pass through B, their moments will be 0. And so we avoid the calculation of the friction of the wall, whose coefficient of friction has not been given. So take moments about that top. It means the forces that will be having a turning effect on the ladder will be the 20 Newton weight, the friction of the floor 10 newtons, and the normal reaction of the floor 20 newtons. Now the friction and the weight all have a clockwise turning effect on the ladder, while the normal reaction of the floor has an anti-clockwise turning effect on the ladder. The next thing we need to do is to get for each of these forces the normal or the perpendicular distance of each of them from the line joining the top of the ladder. In the case of the weight 20 newtons, the normal distance or the perpendicular distance of that weight is A sine theta, and that of the normal reaction is 2A sine theta, while that of the friction of the floor, the perpendicular distance from the point B, would be 2A cos theta. So by the principle of moments, then we have that the sum of the clockwise moments must be equal to the sum of the anti-clockwise moments. So 20 newtons into the perpendicular distance, which is A sine theta, plus 10 Newton friction of the floor times its unperpendicular distance, which is 2A cos theta, should be equal to the moment of the lone force 20 newtons turning the ladder anti-clockwise, 20 times its unperpendicular distance, which is 2A sine theta. So to simplify, we start by observing that 20A is common in each of these terms. So I cancel 20A, 10 times 2 is 20, so 20A there, and then 20 cancels A. And the next step will be to divide through by cos theta, so that I get sine theta over cos theta over cos theta all over cos theta, and that gives me sine over cos, which gives tan theta, plus cos over cos, which gives 1, equals sine 2 sine theta over cos theta, which gives 2 tan theta, and making tan theta the subject, we have that tan theta equals 1, and tan theta equals 1 means that theta is tan inverse of 1, which is 45 degrees. In the next question, we have x, y, and z are moving particles. The velocity of x is 4i plus 5j meter per second. Relative to x, the velocity of y is 3i plus 2j meter per second, and relative to y, the velocity of z is 5i minus 3j meter per second. The true velocity of z is, and you have these options. So we have been given velocity of y relative to x, so vy relative to x, which is supposed to be vy minus vx. So with this, we know vy relative to x and we know vx. So vy would be vy relative to x plus vx, and vy relative to x is given as 3, 2. We add vx, which is 4, 5. So we get 7, 7. So vy is 7, 7. We also have that relative to y, the velocity of z is this. So vz relative to y is vz minus vy. So vz should be vz relative to y, which is 5, negative 3, plus vy, which is 7, 7. So we have 5 plus 7, which is 12, and negative 3 plus 7, which is 4. So it gives 12, 4. And that is option A. In the next question, we have a particle moves so that after t seconds, its position vector r equals 4t minus 1i plus t squared j plus 15t minus t cubed k in meters. The speed of the particle after 3 seconds is, and we have these options. So we remember that speed is supposed to be the magnitude of the velocity, and since we have position vector, if we differentiate it with respect to t, we will get the velocity. So v is r dot, that means the r dt, which is equal to 4i plus 2tj plus 15 minus 3t squared k. That is in meter per second. So when t equals 3, we have that v should now be 4i plus 2 times 3, which is 6j, and then plus 15 minus 3 into t squared, that is 15 minus 27, which is negative 12k. So that is the velocity in meter per second. But we have been asked speed, and speed is supposed to be the magnitude of the velocity, which gives you the root of 4 squared, which is 16, plus 6 squared, which is 36, plus negative 12 squared, which is 144, and that gives the root of 196, which is 14 meter per second, and that gives C. In the next question, we have a sphere of mass 2 kg collides directly with another sphere of mass 8 kg. Both spheres are moving in the same direction with speeds 3 meter per second and 1 meter per second respectively. Given that the 2 kg mass is brought to rest by the impact, the equation of restitution between the sphere is, and we have these options. In order to calculate the equation of restitution, we need to get the initial velocities and the final velocities for both particles. One of them has not been given, so we use conservation of linear momentum to get that missing velocity, and then now use Newton's law of restitution in order to get the coefficient of restitution. In order to conserve momentum, we have the first particle of mass 2 and with velocity 3, while the second particle is of mass 8 kg with velocity 1. So m1u1 plus m2u2, we get 2 into 3 plus 8 into 1, which should be equal to the mass of the first particle into 0, since it's brought to rest after impact, plus 8, the mass of the second kilogram, into its velocity, call it v2, which we are looking for. So we have 8v2 equals 14, so that v2 equals 7 all over 4 meter per second. So using Newton's law of restitution, then negative E equals v1 minus v2 all over u1 minus u2, and we get 0 minus 7 over 4 divided by 3 minus 1. So negative E should be negative 7 over 8, so that E equals 7 over 8, and that gives option B. In the next question, we have that the work done by a force F equals I plus 2J plus 3K newtons, which moves its point of application from a point P with position vector RP equals 3I plus 4J plus 5K meters to another point Q with position vector RQ equals 7I plus 6J plus 5K meters is, and we have these options. So normally the work done by a force vector in moving a particle through a displacement vector PQ is supposed to be F dot PQ, and F is 1, 2, 3 in column form, dot PQ, which is actually RQ minus RP. So 7 minus 3 gives 4, and 6 minus 4 gives 2, while 5 minus 5 gives 0. So at the end, the dot product gives 1 into 4 plus 2 into 2, which is 8 joules. The correct option is D. In the next question, we have that a car of mass 120 kg moving with a speed of 12 meters per second has its engine working at 54 kilowatts up a road inclined at an angle sine inverse of 1 over 5 to the horizontal. The non-gravitational resistance to the motion of the car is 300 newtons. Taking G as 10 meters per second squared, the acceleration of the car is, and we have these options. So for motion up an inclination, we can start by drawing the car. The angle is theta, the horizontal. The forces acting on the car up the line of greatest slope of the hill is P over V, power divided by the instantaneous velocity V, while the opposing forces, we have the non-gravitational resistance R and the component of the weight of the car down the road, which is mg sine theta. So by Newton's second law of motion, we have that the engine thrust, which is P over V minus R minus mg sine theta, should give the resultant force on the car up the road, which should be equal to the mass of the car times the acceleration. And the power given in the equation is 54 kilowatts, which is 54,000 watts. You need to convert to watts to have consistency of units, all over the speed of 12 meters per second, minus the resistance given as 300, minus mg sine theta. M is 1200 and g is 10, while sine theta is 1 over 5, since sine inverse of 1 over 5 gives theta, and that should be equal to the mass, which is 1200, into the acceleration that we are seeking to find. Dividing through by 100, we have 2 zeros in each term cancelling, and then 540 divided by 12 gives 45, minus 3 minus 5 cancels 10 to give 2, so 12 times 2, which is 24, should be equal to 12a. So that dividing through by 3, we have 15 minus 1 minus 8 equals 4a. So a equals 15 minus 1 minus 8, it gives 6 over 4, which is 3 over 2, or 1.5 meter per second squared, and we have option B as the answer. In the next question, we have taking G as 10 meter per second squared, the work done in lifting 8 blocks, each of mass 12 kilograms, from the floor onto a shelf of 2.8 meters high is, and we have the following options. In the case of lifting weights up a vertical height, the work that must be done, W, equals the gain in potential energy. Here, however, we have 8 blocks involved, so total work that is done will be 8 times the mass of each block, which is 12, times G, which is 10, times the height, which is 2.8. All that multiplied out gives 2,688 joules of work, which is option A. In the next question, we have that a car accelerates uniformly from a velocity of 10 meters per second to 60 meters per second in 6 seconds on a straight level road. The distance covered by the car is, and we have these options. So here we have been given the initial velocity U as 10, we have the final velocity V as 60, and then T as 6 seconds. They want us to calculate the distance. The best option to use, since the acceleration has not been given, to avoid calculating it, we use simply the formula S equals average velocity times the time. This gives us the answer faster than using any other equation of motion. So we have the initial velocity 10 plus the final 60 all over 2 times 6, the time. Now 10 plus 60 is 70, and 6 over 2 is 3, so 70 times 3 is 210. meters as the distance, so option C is the answer. And finally, for the last question, which involves probability, we are given that the events A and B are such that P of A given B is 11/21 and P of B is 3/5. Then we're asked to find P of A intersection B. In order to calculate P of A intersection B, we make use of the available information. P of A prime given B is supposed to be P of A prime intersection B all over P of B, so that P of A prime intersection B can be found by cross multiplying P of B and P of A prime given B. That gives the product of the two should be 11/21 times 3/5, which gives 11/35. And now P of A intersection B is P of B minus P of A prime intersection B. That gives P of B, which is 3/5 minus 11/35. So here the LCM is 35. 35 divided by 5 is 7. 7 times 3 is 21. Minus 35 divided by 35, 1 times 11 is 11. So we have 10. 21 minus 11 is 10/35. Dividing by 5, we have 2/7 as P of A intersection B, which is option D. Thanks for watching, and if you did find the tutorial helpful, support us by subscribing to the channel, liking, commenting, and sharing to your friends so that they get to know more about the channel for more interesting videos.